Welcome back. We'll quickly see the code execution that we had done for hierarchical clustering. Step 1, we are importing certain important libraries, setting the working directory, importing the customer spend data. We are now going to go do the distance computation. For distance computation, we are using SkyPy spatial distance package from which we are importing the pdist and the square form function. We call the pdist function. Pdist is for pairwise distance. Between each observation in the data, it is going to compute the distance. To represent the data in a square form, I'm using the square form function on the d_euc, which we got in the previous step. Having computed the square matrix, we now build the hierarchical clustering. For that, we require linkage, dendrogram, cut tree functions. We call the linkage function. Method is equal to average. So we are using average linkage. And this piece of code is going to plot the dendrogram and giving appropriate X label, Y label, and so forth. On seeing the dendrogram, we see observations which are named as A, B, C, D, E. Those customers which are named as A, B, C, D, E are on the right hand side and F, G, H, I, J on the left hand side of the cluster. Basically, this entire clustering has happened completely based on the average monthly spend in our data. To quickly show you that it has based on average monthly spend, this is the outcome of the data on which we are running the codes, and you can see the initial 5 observation A to E, they've got high average monthly spend, and F, G, H, I, J have got low monthly spend. The other attributes like the number of visits, apparel items, FNV, staples, they have got less weightage or zero weightage in this entire calculation because their values are too small. And in a Euclidean distance formula, x2 minus x1, 2 minus 3, that is 1, the whole square, as compared to 10,000 minus 7,000, the whole square. This 1 square is very negligible value in front of that. So the entire calculation of spend has happened, of clustering, Euclidean distance has happened on spend. That's what I had mentioned in earlier session, that when we do clustering, we should do normalization or standardization of variable. So above clustering was done without scaling. It can be clearly seen that clustering has happened only on the spend variable. Other variables has got no influence on the clustering outcome. The variable with wider range and larger values are dominating the output. Moreover, when we are doing the formula x2 minus x1 the whole square, rupee minus rupee the whole square, plus y2 minus y1 the whole square, visit minus visit the whole square, rupee minus rupee the whole square, and visit minus visit the whole square. Adding these two terms having different units does not make sense. So from that point of view also, when we standardize or normalize, the variable becomes unit free. So whenever we do clustering, you have to remember scaling of the variable is an important step. So let's quickly do scaling of our variables. For scaling, I'm using sklearn.preprocessing and using the scale function from it. Having done the scaling, let's move forward. We now call the pdist pairwise distance function on the scaled data frame, scaled array, and the linkage algorithm is also called with method is equal to average. Let's print the dendrogram. So this is the dendrogram. This time around you see A, B, C, D, E, which were high monthly spender customers, they are not together, which means other attributes also has got reasonable weightage in the distance calculation. I would now like to explain you how this entire distance part, which is coming in the dendrogram, comes into play. To show that, what I have done is this entire distance matrix which is shown here, I have taken this entire distance matrix in Excel. So this is my Excel where the entire distance matrix is there. From this distance matrix, let me make it full screen here also, auto hide. Yeah. So here you can see the distance between customer A and A is 0. Distance between customer B and B, the diagonal has to be 0 because distance with respect to itself is 0. 4.48 on the scaled dimension, the distance between customer A and customer B is 4.48. Now, how is the hierarchical clustering working? The way the hierarchical cluster works is, first it computes distance between each object with other object. So here objects are customers. So distance between customer A to J has been computed with respect to customers A to J. In this entire matrix, you have to locate where you get the minimum distance. In this, where I get the minimum distance is somewhere here, 0.77, the cell where it is marked, or probably I now color it with yellow. So 0.77 in this entire matrix is the minimum. So as a first step, the customer H will get merged with customer I. The cluster H will get merged with cluster I. So this is what would have happened. So H and I gets merged. Now HI is a cluster. You compute distance of HI with respect to A, HI with respect to B, HI with respect to C. How would distance of HI with respect to A be computed? If I have to compute distance of HI with A, I have to take this value 3.58 and 3.73. Linkage algorithm, what you have mentioned is average. So 3.58 plus 3.73 average will become the distance of HI with A. If I have to compute distance of HI with B, I have to take 3.80, 3.58 average of that. So this way, for HI cluster, you can now recompute the distance with A, B, C, D, E, F, G and J. And remaining distances are all available on the matrix. Whichever distance is minimum, that two objects are now going to get merged. In the entire calculation, it seems Fj came out to be minimum, that is 1.31. So where is Fj? Somewhere here, 1.31, this one. So this would have come as minimum in the next iteration, so they get merged. Again, you recompute distance between the clusters. Whichever comes out to be minimum, probably 1.33, which is between C and D, turns out to be minimum, that gets merged. Then distance between EG, 1.48, that turns out to be minimum, that gets merged. Now you've got this level. This level, if you see on the dendrogram diagram, it shows you first HI got merged, and if I can now neatly put a straight line here, it will not be that neat, but still with the best of my effort, if I can put a straight line here, it will come somewhere here. So this y-axis is the distance, that is representing where the merge of the two clusters happened. Then next merge was between F and J. And once again, if I can put a neat line here, F and J would be somewhere here, and then this C and D and so forth. Let me delete those lines, yeah, and come back to Excel. This calculation keeps happening. Now just for your understanding, HI, Fj, distance. So how I compute the distance between these two clusters? From the matrix, I have to see H with F, 2.48, I take that value. From the matrix, H with J, 2.23, I take that value. And this way I take all combinations, all objects of cluster 1 with respect to cluster 2, I put the values and average, because we said linkage algorithm method is equal to average. In case if I would have said linkage algorithm method is equal to minimum, the distance in this case we will have to take the minimum of that, these four. If we would have said maximum, we would have to take maximum. I hope the linkage algorithm is now understood. This is how the linkage algorithm works, and this is how internally it keeps agglomerating. In the diagram, you cannot show all other distances which are not important at that level. Otherwise, this diagram would have become too complicated. Only the linkage, which is the satisfying criteria based upon the linkage method, only that linkages, those joining of clusters are shown in the diagram, and this is how you get the entire cluster diagram. So what I can now do is minimize this slightly. So this entire diagram is coming on the same screen. This is how you get the entire diagram, which is represented as a dendrogram. And we already saw how to see how many clusters. The way to arrive at number of clusters is by putting a line. So if I put a line here at 3.5, this line is cutting here vertically and here vertically. It means two clusters, but two clusters, then this would become part of this cluster, which I do not like, because these two seems to be a different cluster. So by putting a straight line, horizontal line, you have to see how many vertical lines it is cutting. The point where it is cutting a vertical line, that many number of clusters you are going to get. From this, we would take a call that we require 3 clusters. Okay. Now, having done that 3 clusters, I would like the data to come into my data frame table. Each row to be labeled, whether it is part of cluster 1, whether it is part of cluster 2, or whether it is part of cluster 3. So here, cut tree function is used. We use the cluster2 and then 3. What we are saying is the cluster should be broken into 3 clusters, and the numbers, the labels will get introduced in our data frame, because on the left hand side I'm using our data frame and creating a new column, clusters. This part of the code, when you execute, let me remove this code and we write now here, having done that, RCTF. Can you see this new column getting introduced? Clusters, where it is now saying row named as A belongs to cluster 0, B belongs to cluster 1, C belongs to cluster 0, 0, 1, 2. So 3 clusters, 0, 1, 2. It has given the clusters as sequence numbers below. Once you have done clustering, the next step in clustering is validating the number of clusters. If you go back to your presentation earlier slide where I had shown you the steps, if you recollect these steps, formulate the problem. We formulated the problem by deciding number of the variables, decided the procedure, we took hierarchical, select the measure of dissimilarity, we said Euclidean, choose the linkage algorithm, we said average, execute the code, get dendrogram, we executed the code, decide on the number of clusters by seeing the dendrogram, we decided 3 clusters, interpret the cluster output. Now we have reached this level, interpretation of the cluster output. When we say interpretation of cluster output, it means profiling. Profiling means creating descriptive statistics of a given group. Groups here are clusters. And when we speak of descriptive statistics, when we speak of profiling, you should always remember 2 points. If the variable is a continuous variable, the most important descriptive statistics is the mean statistics. If the data is a categorical variable, the most important descriptive statistics is the proportion statistics. In clustering, you cannot use categorical columns. For example, gender, you cannot use gender column. How do you use categorical columns in such a case? The categorical columns are used by converting them into 1-0 dummy matrix. That is one hot encoding. So for example, you have got a categorical column like gender. You have to create a column, say is male. 1 for male, 0 for female. If you have got a categorical column, say occupation, salaried, self-employed, professional, you will have to create a column salaried, all customers all observations where the people are salaried, you have to mark as 1, others 0. Self-employed, everyone who is self-employed you should mark as 1, others 0. Professional, everyone who is professional mark as 1, others 0. So basically this is how you convert them into a 1 0, and these 1 0 columns are then considered into clustering calculation. You cannot use the occupation. However, occupation has now become part of your clustering calculation. But if you have to do profiling, you have to go back to your actual occupation column and then say what proportion of customers in a given segment in a given cluster are salaried, what proportion are self-employed. Now when I see the cluster profile, the way I would define a cluster profile is, if I see in a given cluster 80% are salaried and remaining 20% are self-employed or professional, I would say this cluster is dominated by salaried segment. That will become the important profiling characteristics of the cluster. Along with it, there will be other attributes which is going to define the profile. But the point I am trying to make is, if the variable is a categorical variable, proportion is the way to see the descriptive statistics, the profiling characteristics. If the variable is a continuous variable, in that case mean is the most used. Okay, you may use other profiling statistics also. You can use median, you can use mode, but most often we end up using mean. But if you feel there are so many outliers, then you may rely on median also. Okay, so here in our case, because the variables that we are working with are all numerical, so when I run the code, I'll simply do group by cluster. At a cluster level, I am doing the profiling and I want to take the mean statistics of all the attributes. So I run this piece of code and get the cluster profile. You can see the data is aggregated at a cluster level. At a cluster level, I can see the cluster 0 has got average monthly spend of 7,833. Cluster 1 has got average monthly spend of around 5,000, and cluster 2 has got average monthly spend of around 2,375. On a spend level, I can clearly see these customers have got different spend capacity. Those who are in average monthly spend, they come around 4 to 5 times in a month. Those who are in a 5,000, they also come around 4 to 5. Now cluster index 0 and cluster labeled 1, both of them are coming 4 to 5 times in a month, but one of them is spending 5,000, the other is spending 7,500. Why is there difference in the spends? There is some other characteristics. That some other different characteristics in this case is apparels. Cluster 0, they spend on apparels, whereas the people, the customers who are in cluster 1, they are not spending on apparels. As a result, the spend of cluster 0 is higher than the spend of cluster 1, despite both of them coming same number of time. Where are cluster 1 people spending? Cluster 1 people are spending more on F&V items, fruits and vegetables. Why is cluster 2 coming less number of time? The cluster 2 is coming less number of time because they are not spending more on F&V. F&V items are something that we regularly consume, which means that it has to be a more periodic visit. However, the people who are in cluster 2, they are spending less on F&V, they are spending more on staples. They come stock the staple items and then don't come at a higher frequency. These three clusters are helping me get segments from my data. While I have put these attributes, I can add one more attribute here, which is how many observations, how many customers are there in each of these clusters. It's also equally important, right? You should know of the total customers, how many customers are sitting in each of the clusters. So you can write some Python code and get that in cluster 0 I've got 3 customers or 4 customers. So here from data it clearly shows there are 3 customers in cluster 0, 3 in cluster 1 and 4 in cluster 2. So that additional attribute will be the part of the defining characteristics, but that is not the characteristics, that is the population in each customer, proportion of population in each cluster. Once you feel that the defining characteristics make sense, the last step in clustering is validate the cluster. What do you mean by validating the cluster? Why would you do clustering of your customers, of people who are coming to your supermarket or hypermarket? Why you want to do segmentation of these customers? Just for the sake of learning clustering procedure? No. A business never does any activity for fun. They want some real concrete outcome, real measurable value out of that exercise. And if you're a marketeer, the reason why you do segmentation, the reason why you do clustering is always, can I create my offerings, products, services specifically at a segment level? If you feel from this clustering, I can have a marketing strategy at a cluster level, then your clustering goal is achieved. For example, if I see the cluster 0, they are apparel buyers, whereas cluster 1 and 2 are not apparel buyers. If I put my marketing hat, what I think, if I get new fashionable designer wears, if I have to run a campaign, I have to invite people. I'm not going to invite 1 and 2. I'm going to invite customers in the cluster 0. Why? Because they come and buy apparels. So if I communicate to them that new designer wares have come to my store, they are more likely to visit because they are willing to spend. If I have to organize end of season sale, in that case, I may target customers who are in 0, but I would definitely target customers who are in 1 and 2. Why? Because I know the people come to my store. I know they are shopping in FNV. They are shopping in staple. But my objective is cross-sell. During end of season sale, I offer 20%, 40%, 50% discounts. So probably if I can cross-sell at end of season sale and make some of these customers who are in cluster 1 and 2 to start buying from my apparel department, probably going forward they may start buying things also. So from that point of view, I'm very clear that cluster 0 makes sense to me. Now let's see cluster 1. What are these people buying? FNV. They are buying heavily on FNV. If I think of FNV, with season change, what happens is the fruit changes. There is early arrival of fruits. For example, when summer starts, just about to start, mango comes up. Mango fruits are there in market. The initial lot of mango fruit is always expensive. They come at a cost of 500 rupee dozen, 400 rupee dozen. Now you get 400 rupee, 500 rupee, you get 3 dozens, 4 dozens. But the initial arrival is always expensive. And if you are getting the initial arrival in your store, if I communicate it to someone who is in cluster 2, less likely they will buy, because when the cost is low at that point also they are not buying. So initial arrival, if I have to invite, I'll invite cluster 1 because they come here to buy that item. What do I target to cluster 2? During harvest season, you get new grain. Rice seasoned rice, old rice is better, is more expensive than the new fresh harvest. But when you get a new fresh harvest, the cost is lower. So whom do I invite? I invite cluster 2 because they come for staple items. They want to buy, they will be willing to stock because they want lower price. So when there is a new harvest, new fresh arrival of grains, probably I'll target them with the new rice. Old rice I'll still go and target cluster 2 because old rice is better. So I'll target that to cluster 2. But new rice, low cost, I'll target cluster 3. Sorry, cluster 2. Index based on index. So old rice, I'll go with cluster 1. New rice, new harvest with cluster 2. So if you think that the clustering outcome makes sense from these kind of actionable, only then your clustering exercise is completed. Okay. With that, you finally end up into the last leg of the exercise, which is naming ceremony. I'm not saying that you call everyone, invite, just like you do a naming ceremony of children, but what I'm trying to say is you should give appropriate names to clusters. The idea being you can use that name for easy communication. For example, if I say I'm a marketing manager, I am speaking to the IT department and I say, hey, pull out the data of all customers belonging to cluster 0. The IT department person, the software engineer, will first scratch his head and start thinking of this cluster 0. What filter should I apply? What is the attributes of this cluster 0? He'll have to go and think of documentation, where in documentation it would be mentioned cluster 0 are high average monthly spenders, they are have more visits, they are apparel buyers. The most distincting characteristic of this cluster is apparel buyers. If I say get me data of apparel buyers, I name this cluster as apparel buyers, it becomes self obvious, self explanatory. Likewise, if I say cluster 1 I name as FNV lovers, it becomes very clear that these are people who come for fresh fruits and vegetables, green veggies. Cluster 2 I'll call only staple buyers. Some name. I'm not saying I'm giving the best of the names, but something which makes the cluster self explainable. That kind of name, it becomes very easy in communication. So that is the last step. Once you have done your clustering exercise, give appropriate names to the clustering. In this case, you see there is no output. There is no output. What I mean is, in this case, there is no model. Let me correct myself. Output is there. In this case, there is no model. You feed a data to the algorithm, and that data has classified the records into certain clusters, segmented the data into certain clusters. Did you get any equation? No, you did not get any equation. So it worked on the data. If I have to now classify, put a new record in an appropriate cluster, probably what I may have to do is take that new record along with all other records, rerun the clustering algorithm. But this is what we don't want to. Because as you keep getting new data, will you keep running the clustering algorithm again and again? No. So this step is where we have to convert this unsupervised into a supervised algorithm. There are definitely other ways also by which I can put this new record in an appropriate cluster. However, that step of how to put a new record in one of these three clusters, we are going to see when we complete our k-means clustering algorithm. For now, we conclude the hierarchical clustering algorithm. These are the codes, these are the details, descriptions which we have all discussed. We now move into a partitioning clustering, that is the k-means clustering. which we are going to see in our upcoming session. Till then, thank you. See you in the next session.